Okay, so we're going to do just a quick little mini lesson on logarithms for the ACT. So when you take the ACT, there's usually no more than 2 logarithm problems on an ACT. Sometimes there won't be any, but the most will be 2. So first we'll talk about a logarithm. So you can go between exponential form and logarithmic form, okay? So this is the log form. And so y equals log of base b of x if b to the y power equals x. So here's an example. We have log base 32 equals 5. You can rewrite that because this is b, this is x, and this is y. So b to the y equals x. So log base 2 of 32 equals 5 because 2 to the 5th power is 32. The same works with a natural logarithm. A natural log has a base of e, okay, and it's just written as natural log of x, okay, or natural log of whatever you're taking the log of, okay. So, like I said, there's going to be a max of 2 logarithm problems on the ACT. If you have 2, one of them can be done in the calculator and one of them will have to be done by hand. If you have a logarithm problem that can be done in the calculator, there are 2 different types, okay? You can have evaluating a log, and so we'll do this one. So log base x of 16 equals 2. So first, if you know that you can rewrite this as b to the y equals x, you can change this to x squared equals 16, and you can take the square root of both sides and know that 4, or x equals 4. Sorry, I should have switched that around. So x equals 4, so that's b. You could also do some guess and check. So you could grab your calculator, and let me see here. Let me go to the home page. All right, so you could grab your calculator and you find your log by doing control x to the 10, or 10 to the x power. So we don't know our base, so that's what we're going to guess and check, and then we have 16. So we can start first with number 2. We can do log base 2 of 16 is 4, so that's not 2. So we can do it again. We can say log base 4 is 16, and that does equal 2. So that is our correct answer. Okay, the other type of log problem that you can do in the calculator will be a graph. Either you're shown a graph and have to pick the equation, or you're given the equation and you have to pick the graph. Ideally, it'll give you the equation. That way you only have to type one equation in the calculator and then find the answer. If you have a graph, you can do it a couple different ways. With this specific problem, you could go to your graph page in your calculator, and I'll show you mine. So you can go to the graph page in the calculator, you can hit the tab button, and you can type in each of these equations and see which one matches, okay? And you could also, if you know that what an exponential graph looks like and what a logarithmic graph looks like, you could use what you know about transformations to figure out what's going on here, okay? So I'll just show you real quick. So this exponential graph, so that's 3 times 2 to the x power. So if I hit enter, that tells me that my shape is like this, okay? So that doesn't look anything like this, okay? So we can eliminate a and b, okay, because those are exponential. So these are logs, and the tell about a log is always this shape, and normally it's at the point 1, 0. That's normally where it crosses the x-axis, okay? So you could you could type this in your graph and see what happens. So we have log base 2 of x, and then this one is plus 3. Okay, so that one's close. That shows you it's here right on this line. Okay, and so that's more of our shape. So that tells you it's going to be one of these 3. It's not going to be that one. We just tried it. If you know anything about your transformations, we know that this number on the outside moves it up or down. The number on the inside moves it left and right. and this number multiplied in front makes it skinnier or fatter, okay? So if you know that the log is normally here, this one is adjusted 3 to the left. So that means D is your answer, okay? But again, you could keep typing those in the calculator and see which one matches. Okay, the other type of logarithm problem you might have requires you to use one of the properties. So these are very similar to our rules or properties of exponents, because logs and exponents are connected because you can go back and forth. So that's why the rules are going to seem similar. So if you're adding two logs, you can condense using multiplication, so you can turn it into one log with multiplication, and you have to have the same base. So if they have two separate bases, you can't condense them, but if they're the same, you can. If you have subtraction between two logs, it turns into the division of one log, and if you have an exponent, it turns into the coefficient. And you can also go backwards. You can expand a log. If you have multiplication, you can turn it into addition, division into subtraction, and a coefficient into an exponent. Okay, so we'll practice a couple and then we'll be done. So if you look, it says condense the expression into one single logarithm. So we're going to condense this. So I have a coefficient. I'm going to turn that into an exponent. So that's going to be log base 4 of p cubed. Okay, and then I have 5 log base 4 of q, so I'm going to change that to an exponent as well. So log base 4 of q to the 5th, and then I have minus. I'm going to do the same thing with this one. I'm going to put the 2 on the r, so log base 4 of r squared. Now I can just go straight across, so I have addition. That's going to turn into multiplication, so I'm going to have log base 4 of p cubed q to the 5th, and then I have minus log 4 r squared, log base 4 r squared. So I'm subtracting, so that means I'm going to divide by that r squared, and that is our final answer. Okay, and so if you've got multiple operations, you just go from the left to the right, just go straight across. All right, number 20, we can do the same thing with a natural log. Okay, the same rules apply. So natural log of 3 is just that. Next, we're going to take this 2 and turn it into an exponent, so we have the natural log of m squared. And then the other two, we're just going to bring them down because they don't have any coefficients. Now we're going to go straight across. So these are adding, so we're going to turn that into multiplication. So the natural log of 3m squared. We're subtracting the natural log of n, so we divide by n. We're subtracting p again, so we put p on the bottom. And that is our final answer. Okay, so like I said, a maximum of 2 log problems on the ACT, one in the calculator, one without, and you might have an ACT that doesn't have any. But if you do, if you will learn these rules and know how to type them in the calculator, you should be good to go. Okay, if you have any questions or want to know more about logarithms, I can work with you. I can do some more examples, some more problems with you. Just let me know. But have a great rest of your day.